Welcome and thank you so much for joining SPORE's Introduction to 3D Printing class. This is a class we do every 2 months, and this class basically we're going to go over some of the basics of 3D printing as well as a spotlight on 3D printing of food, which is an upcoming industry by itself. So a little bit about us. SPORE stands for Supporting Public Outreach, Resources, and Education. We are an outreach program by an NGO called Mycelium, whose mission is to accelerate the circular economy using open source technology. So we focus on different projects that bring sustainability, either environmental or social sustainability using technology, and we're located in Huntsville, Alabama. So this class will be presented by Jeanette Glasius, who has a decade of experience in 3D printing, and we're just going to go over an introductory class on 3D printing along with a spotlight on 3D food printing. So Jeanette, I'll let you take the class.
That's right. Thank you, Ankur. And I'm really sorry about the technical difficulties, everyone. But this class is a basic intro into 3D printing. And here's the course overview. If you can see my screen, we're going to go over what is 3D printing, the types of 3D printers there are, how to get started in 3D printing, how to set up your models, and then a few last-minute send-offs on how to actually print. And then here we're going to also talk on the topic on food 3D printing. So first we're going to go into what an actual 3D printing does. Basically, in a nutshell, 3D printing is taking a digital 3D model and turning it into a physical object using various different applications. So yeah, basically 3D printing is changing the idea of having warehouses of parts and instead having it as a machine that can make the parts on demand. So here's a few applications that I use 3D printing for. I'm kind of a nerd, so I just kind of make cool stuff around the house. When COVID hit, I was making PPE for the local community. I'm really big into cosplay, so I've got several cosplay pieces. There's a building in the town near me that I 3D modeled the building and gave it as a gift to someone, replacement parts. And then also you can have some food grade applications such as these cookie cutters that I made out of the Saturn V design. And here's a robot that Dan had made that, Dan, are you able to talk a little bit about this robot? I don't know if he's able to jump in, but it's a robot that he had designed, and his overall goal is to make this robot that can have a printer.
Sorry, I had to grab Uncle's phone. So this robot I built with a 3D printer and just some servo motors and an Arduino. So the goal with it is to attach a 3D printer.
Yes, so the idea is to have a 3D printing head on this robot so it can print more parts as it walks. Here's a little bit more of some in-depth into the cosplay aspect that I've done with 3D printing. So from start to finish, you print your parts, or you design them up and print them, and then you prime and paint them, insert lights, and then assemble them. And then I've done various different applications. I made Sephiroth's 9-foot sword. I did teeth with non-toxic materials. I've made various clear plastic pieces that I put lights inside. And then here's a piece that I 3D printed and actually melted over a resin stone. And it's really, really it's been a huge upbringing with the cosplay community. And it's a game changer. If you're into cosplay, I recommend looking into getting into 3D printing. So here's the spotlight of the month. It is 3D printed food. So I kind of broke this into two different categories. There is 3D printed meat that is basically, right now it is only available in laboratories. And then there's some commercial 3D printers that either you can, a commercial 3D printer, which will be, 10,000 or so. And then they have a few that are a little bit more affordable that you can get at home. And so here's the image that I used for the class. This is actually a hummus that they had printed a castle out of, and candies are popular. So the basics of the lab printed meat is they basically take the cells of an animal and they kind of grow them either in agars or in serum, and they get a bunch of cells from this one group of cells, and then they put this cell paste into a bioprinter and they print it into patterns that would replicate what a steak or whichever would look like. And then it in this diagram they're showing it being ground up into sausage, and then basically you've got a sausage made out of printed meat. But there are some like KFC experimented with a bioprinted chicken nuggets, and then also there's a group that is looking for making different types of meat with 3D printing. A lot of them are also looking for meat alternatives. They use like a pea proteins for vegetarian and vegan options. The advantage of switching to bioprinted meat is that's far less resources needed. That's less water, less land, less methane production. There's just an overall smaller carbon footprint with bioprinted meat. Unfortunately, it's not to a point where it can be mass produced, but if we were to grand scale what we have now, it's already better than what we're already doing. It's also a more humane option for meat. So if you're worried about animals, you're only taking a small piece of animal cells to make this type of printing. To make a steak, you're not having to slaughter an animal for it. So it's also a humane option. It's also a good option for special diets. There's certain people who can't eat certain kinds of meat because of their diet, or like especially like life choices. If you don't want to eat meat, then it's an option where you're not actually eating meat. And then also there's an interesting article that I found on unique flavors. So this came up as always, as all odd conversations come from Reddit. There was a conversation about turducken and how turducken. The idea of turducken is to take multiple meats and make a special, different kind of flavor. And so this bioprinted meat is kind of bringing to the table the idea of mixing different animals into this process to make unique flavors. And it's, they're making all kinds of crazy ideas of what they should try to put in these things. So really, it's opening the door to the future. I really think it's really, really interesting with bioprinted meat. So here's the next slide is going to be the commercial and home use printers. It's basically most printers, I believe, are a lot like the regular printers that you see today, where it's basically squeezing it out and then making a layer. And we'll kind of go into the mechanics of that later, but it just puts layer after layer. And then the second one is the powder type, where it's got a basin of powder and it's basically printing on top of it with some kind of binder, some kind of hardening liquid, or in some cases they'll have a laser that will sear it and harden it that way. So down here I have a few examples. So these two images here are from the Foodini website, which is a pretty popular commercial food printer, and you can visit them at naturalmachines.com, and they actually sell this printer. I believe they're $4,000 to $20,000. They have different sizes. You'll have to you can check out they actually have these machines available for purchase. So that's pretty cool. You could just fill it up and then it'll print in whatever medium you want. And then there's another printer that actually we as a group have been looking at for a possible event in the very future of having like a pancake benefit. And this printer will print in pancake and make a design. And so it's really like, I think of people are really like, actually these are sold out right now. Like you can't get these printers right now because they're so popular. And then you've got these candies that, like I said, they're probably printed in the binder type. and you can do all kinds of neat shapes. And then you've got this odd thing here that I've seen pictures of, and I always was interested to know what exactly was going on here. So I found an article on it, and what it is this the scientist designed this print design where it prints this dough, but as it prints, it actually prints like seeds and substrate inside the dough that's edible. And so what you do is you print this piece and then you put it in your windowsill and you let all this vegetation grow, and then you eat this salad dough thing. Like, I always thought that was really, really cool. Like, you just literally grow your lunch in the windowsill and then you just eat it. Very, very cool. So I've got a few examples up here. You can candy chocolate dough, cheese, pasta, mashed potatoes, gels, protein powders. It's popular to use like cricket powder, or some people have a food. It like turns your leftover food into like a powder, and you can print in this paste and have yourself a very nutritious meal from leftover pieces. The downside to printing food is it depends on the viscosity. If you've got something that's too soft, it will collapse as you print. If you've got it too hard, you run the risk of clogging your printer, and then that's not good because the printer will get you'll get contamination in the printer if you have anything stuck in there. Very, very, very interesting. I definitely recommend looking into 3D printing food. There's so much. This is just a teaspoon of what is going on here. And I've actually rolled around the idea of doing a dedicated class to 3D printed food because there's just so much. There's so much to it. So the next type, these are our like 3D printers out of traditional materials. In this section, we'll go over 3 popular types. There are definitely more types than these 3, but there are many, many, many types of printers out there. The most popular being the FFF or the FDM printer. And the way this printer works is you have this roll of plastic string, and it pulls it into these gears. And as it goes through the gears, it goes through this heated block. And as it goes through the heated block, it becomes liquefied, and it prints in a pattern right here on the bed, just like I was talking about with the food printers. It prints in a layer in a pattern that you preset, when you set up your file. And then it goes up a little bit and it prints a pattern, and then it goes up a little bit and it prints a pattern until you have this bust of Victorian lady that's just for your very own. And that's this. There's lots of other elements, like this bed is usually heated to hold it on, and but this is the basic mechanics of this type of printer. They can be printed in several different kinds of materials. The most popular, I believe, being the PLA, polylactic acid filament, as it's easy to use. It's fairly low temperature. It's not very finicky, not as finicky as some of the others. Definitely easier to use than ABS, which is a stronger material. However, it's ABS is toxic, whereas PLA is non-toxic. It's also PLA is biodegradable, while ABS is not. ABS also has to be in a controlled temperature environment, so it's a little bit more challenging to get your prints to be successful. And then the next one is PETG. It's sort of the best of both worlds. It's strong like ABS. It's non-toxic like PLA. It's still a little bit challenging to use, but if you can get your hands on PETG, if you're making something that you're worried about being biodegradable, I recommend PETG if you can handle the challenges with printing in that. Then there's some other types of materials that you can use. You can use nylon, which is kind of a little bit flexible. And then you have carbon fiber, which is really, really strong. And then you have PEI and TPU, which is almost a rubbery material. And then you have composites, which are They're usually wood infused or metal infused. There's one, I know someone that got the iron infused one. So you print the piece out of this iron material and then you spray it with water and it rusts. So you can make something that really looks like a old iron piece out of this this material. So the next kind of printer I'm going to go over is the SLA printer. And the way this one works, it's basically the same principles, except it's upside down and it's in a liquid. Instead of squeezing plastic out onto a bed, this one has the bed lowered down into this vat of liquid, and a laser, or it's either a laser or an LCD screen, will expose a certain point with UV rays, curing this resin that is sitting in here. So as it cures a layer, and then it raises a little, and it cures a layer, and then it raises a little, and then you've got your piece that you just pull off right off the bed. And I'll see if this video will go. So I've actually got one of these printers. I've got a small one. And I'll talk a little bit more on it later, but they're actually, you can actually get these printers in fairly affordable prices. And Phil makes a good point on I'll go back to the filament. Yeah, the ABS is toxic. Like I said, it was toxic. It's actually toxic to inhale the fumes as it's printing. And it's why I've never actually printed an ABS, because I worry about it making my office smell, or, you know, breathing it in, or my pets breathing it in. So I just prefer to stay away from it. But a lot of people do prefer it because it's very strong. All right. So as I said, I've got a small one. I've got it's actually a longer orange tin that I picked up for about $100, and I've been printing miniatures over the last year. And here's a few pieces that I printed. So this is how it looks when it comes off the printer. It looks very, very clear, very gelatinous. This is before it cures. So once you print your piece, then the idea is to either set it out in the sun or get a UV lamp and let it cure the rest of the way. And this material is actually very, very strong once it cures. The downside is it is a little bit more expensive to operate. There are definitely its own challenges. I find this printing to be a lot more challenging than FDM printing. But if miniatures are your thing, I definitely recommend trying this out. It's been really cool having one of these printers to try this kind of printing with. So the third type of printer I'm going to show is this is a Sinister laser printer, and the way this works is it's a metal powder that it has this vat, and then it has a piston at the bottom, and at the beginning it starts at the top, and so then this roller will roll this powder over the top of this bed, and it will sear a pattern, and then this will go down a little, this will roll out another layer, it'll sear it, and then over and over, pattern after pattern, it has a part. And the downside of this printer is it's very expensive. The upside is you can print in metal, which is you can print in really hard materials. So let's see if I can get. So I found a new video. So another type of powder printer is kind of an inkjet powder printer. And this is actually a Huntsville-based business. So where we're located in Huntsville, Alabama, this company makes these custom 3D printed parts. And you just so they have these kind of booths at Dragon Con where I go, where you go in and you stand on this turntable and they do a 3D scan of you, and in your cosplay. And so then after a little while, you can come back and purchase this action figure of you that they had scanned right there. Really cool if you want like a memento of something. This picture right here in the bottom right is actually from Clemson University. It's a powder printer that they printed at the Sunoco Institute there. It's actually an entirely powder printed bottle of whiskey. This is not a bottle of whiskey. It's just a powder print, obviously out of some clear plastic beads or something. I'm not really sure, but I think this looks fantastic. The fact that if you told me that this was printed, I wouldn't believe you. Because obviously the liquid is probably not going to shake around, but very, very interesting type of printing. And this is the kind of printing I was talking earlier, how they were making candies where they use a binder or a searing. Same kind of principle. So printers to get at home. This is just our recommendations on the types of printers based on price. Obviously, right now, the most popular printer on the market is the Creality Ender 3. Because of everything last year, like these printers, everyone was getting one of these printers. They're just very cheap, very easy to use. And they do run about $150 to $250, depending if you get a refurb or a new one. And then the next one is kind of the big brother to this printer. I've got one of these, the Creality CR10S, and you can get those for about $300 to $400. I believe I got mine about $300 because it was a refurb. They might even have gone down a little. You can probably find them a little cheaper now that everyone has, gotten their hands on one. And then here's a picture of the SLA printer that I purchased last year, the longer orange 10. It's not the best. There are definitely some better SLA printers out there, but this one has been a workhorse, and I really enjoy using it. And then kind of our high-end recommendation is the Prusa series. Featured here is a dual filament, so you can actually print in two different types of material. Here they have two different colors. And they run anywhere from $400 to $800, depending if you want to put it together yourself or if you want to have it pre put together. But they are also really excellent. We donated a Prusa model to one of the smaller branch libraries in our area, and they've been using it for over 2 years, and they still get lots and lots of people asked to use this printer. So I recommend that one if you have the money to shell out for one of these. Just the basic overview of filament and the resin. So a basic 1 kilogram. The filament usually comes in a kilogram, so it usually comes in these spools of plastic, and they are typically about $20. You can get them cheaper. You can definitely get them for more, depending on the type of material or the brand you get. There's, I guess I recommend Hatchbox and Maker Geeks, I believe. Yeah, there's several higher end brands, but you can always choose from what kind of material you want. Definitely go by ratings. Resin, I've been able to buy them for about $20 a half kilogram, and they last a long time. My printer's not very big, so it doesn't take very much to print with resin. I've got red, clear, and blue, and they're really, the clear actually isn't quite clear. It's that yellow color that you saw, but the red and the blue look amazing. And I believe I bought Elegoo brand, and they're pretty good. So I'm going to briefly go into how to get started. So step 1 is going to be finding what you want to print. So there are a variety of sites that you can find models. Thingiverse is usually my first go-to. If I'm looking for SLA prints, I try my Mini Factory. The other upside of my Mini Factory is they print everything first before they allow it to be put on their marketplace. They do have purchasable models, but there are also several free ones. If you really are looking for something obscure, I recommend trying Yegi. It's kind of the Google for 3D printed models. You'll find every database goes through Yegi. And then if you're really still having trouble, you can try Sketchfab. It's more of an artist-based database. Not a lot of models will be downloadable. Then there's Google Earth. I've pulled some models from Google Earth just to print stuff in my local area. And you can find all kinds of stuff. If you want something like a gift that's really personable or in someone's hometown or something, you can modify models from there. Then there's also making your own model. If you're going to try making your own model, it's important to know the two different types of 3D models. There is CAD, which is a more precise, it's a little bit more mathematical type of modeling. Definitely, if you're making a part for something, I recommend trying to use CAD over modeling, 3D modeling, which is a bit more like modeling clay. It's usually with shapes and modifiers and trying to change the surface, however, just to make it look pretty. And we have a couple of programs that we recommend. We have so this program, 3dorchard.com. Dan, I don't know if you want to try and explain a little bit about 3D Orchard. So 3D Orchard, he actually started this up as his own program. 3D Orchard is a CAD-based, browser-based CAD system where you can make models right there in your browser and save them as an SLA. And it's also its own database where you can go in and see what other people have made. And once you have a model and you change it a little, it'll make a branch. And then if you take that and then you change it a little, it'll make another branch, or you can go back and make another one and it'll branch another in a different direction. So if you want to try CAD, it's free. I recommend trying this. If you're more interested about modeling, I recommend 3D Blender. So Blender 3D is a open source program that's been around for, I think, about 15 years. And the interesting thing about them is they're constantly being upgraded by people, just people sending in their suggestions or people upgrading the source code. And one really interesting thing that I enjoy about Blender is every year they have a film festival. And so they'll say, okay, this year I want everyone to make videos about hair physics. And so that year, everyone will make videos about hair physics. And then at the end, they have showcase and awards and all that. And then they say, okay, what do we need to fix about hair physics? So they fix it based on everyone's videos. And then the next year, they'll push just textures. And then they will do something else the next year. So, but in the long run, this program is free. And there's actually some video game companies that use this program. I believe it's Ubisoft uses Blender in their video games. And I think that's really cool that a huge video game company would use a free software that anyone can use instead of using something like Maya, what's expensive. So if you're interested in that kind of 3D modeling, I definitely recommend trying that. It is a little bit complicated, but they do have a lot of beginner videos on their website. And I've been able to get the hang of it. I think everybody has a fair chance. So after you've got your model, the next step is to use a slicing program to prepare your model for your printer. Here's a few programs that I recommend. I recommend Cura. It's free and it's very easy to use, very intuitive. But I'm not a big fan of their support material. I'll explain what supports are later. So if you do know what supports are, I recommend Mesh Mixer. They have these tree supports. I know Cura is starting to develop their own, but Mesh Mixer has been doing it a while, and I really enjoy using those. Then if you're willing to pay a little bit for a slicing program, I recommend Simplify 3D. I believe it's 175. I believe you can get some discounts on it through some various ways, but I've heard that it's incredibly powerful and has a lot of versatility. But then if you're wanting to go further, I don't recommend this for beginners, but if you're wanting to go further, there is Slicer. You can actually go in and manipulate the code to do specific things. So basically what these programs do is you take your 3D model and you turn it into what's called G code, and then you put that in your printer, and your printer will know what to do, and it'll make your physical object. So when you get a slicing program, you have this basic overview. And when you put your model in, you can move it, you can resize it, you can rotate it, mirror it, and then they have some other new modifiers. And so you can do however you want to set it up. So it's important to set it up correctly, or your print will fail, or you'll have trouble printing certain parts. So it's important to know how exactly, what is needed to know for printing. So when you print, you have these different sides. You have your top and bottom layers, you have your outer shell, and then you have your infill. And what your infill is it's what is going to print on the inside of your model. So your print is actually not going to be solid or hollow. It typically uses this pattern on the inside. Cura typically starts with 20%, but you can increase it to 50%. You can even go to 100. It's not really necessary, especially if you're just making something for looks. I typically print stuff for looks, so I go with 7% with thicker walls. So you want it to be really smooth, but it's going to take 7 hours. If you don't have that much time, you can try the middle ground, which is usually people print at 0.2, and that's going to take an hour and a half. Or you can go 0.3, and it's going to be a lot looser, a lot coarser, and you have you run the risk of what's called delamination, where your part will actually come apart, but you'll get it in an hour. So if you just really got to have it, you can go that low. In their basic settings in Cura, you have this table that you can change the settings on layer height, print speed, infill, all that stuff is here. Or you can go with a more in-depth setup. They do have a custom where you can change your build plate options. In the basic, you don't really have this option. So in this case, you have your skirt, your brim, or your raft. And what a skirt is it just prints a little bit around the outside of the piece. And that's usually fine. That's what I usually do, just to make sure it's going okay before it starts actually printing the piece. But if you're printing something really tall, I recommend going with a brim. And so it anchors it to the bed without actually doing anything to the piece. But if you're really having some trouble, or you just, when you're just starting, you can try a raft. And what a raft does is it prints several layers underneath the entire piece. If you've got pretty good adhesion, this is just going to be a waste of plastic and time. So I recommend either none or a skirt once you've gotten everything narrowed down. So as I mentioned earlier, and supports are important. So if you've got something called an overhang, which is these parts that go over where it's going to print, you need something there to hold that up. And so you can print at an angle because of the 45 degree rule, where it prints just a little bit over and then it prints a little bit over. So it has something to hold on to. But if there's nothing there, you're going to get this mess of plastic that isn't going to look good, or it's going to just completely, your piece is going to completely fail. So they do have an option to turn on supports in most slicing programs, and it will automatically generate this material underneath. And this is obviously done, or probably in Cura. They have this type of support, and I don't prefer these because they usually leave a really rough edge and they use a lot of plastic, whereas the mesh mixer one has the little trees that you can just pick off, and they don't actually take up a lot of plastic to use those. So one thing before you send off your file to your printer, I recommend trying the preview menu, where you actually see in real time your printing. So you just move the slider and it prints it so you can look for overhangs that don't have supports or some holes where the file isn't set up right, that kind of thing. So I always recommend looking that up. And then just as a last suggestion, when you save your file, at least the printers that I started with, most of the printers I started with, they don't have a very good interface when you're looking on the printer. So I always name mine with print time starting. So it's when I look through, it says like 2 hours, 4 hours, so on. Printer profile, if you've got multiple printers, I recommend doing that so you don't want to run the wrong profile on the wrong printer, or your printer is going to print wrong. Your motors are going to be trying to go somewhere they can't go. Then the name of the piece, the material, you want to put temperature, anything to help you know when you're going to select your file. Just a recommendation. So our last section is just some tips. So here is my printer. That's where the heating block is, and it's going to print your piece. So my printer has 2 different heating settings. They have you can preheat in PLA or in ABS. When it preheats to PLA, it typically preheats to 190 to 210. And in ABS, it's 210 to 240. And the bed temperature will change as well. It will usually, I have mine set pretty high, so mine prints at 60 degrees, where the ABS, it requires a pretty hot bed to stick to the bed. And that's usually anywhere between 70 to 100. That's Celsius also. That's in Celsius temperatures. One very, very important and also very challenging thing about printing is making sure that your bed is level. On older printers, you have these screws that you have to adjust. Some have an auto level sensor that you can add to your printer like this, or you have to adjust it using the interface. Either way, you have to make sure that your printer is level, or it's going to have pieces that lift up, or you're going to have what's called elephanting, where it kind of smooshes it into the bed, or it overheats it a little bit too. But it's very, very important to make sure your bed is absolutely level, or you're going to have printer failures. So it's good to make sure that you're before every piece. I would recommend. And here's some beginner tips. So it's good to have extra parts, some tools, a scraping tool and a pair of nips is good to take off supports and such. Also, the cool thing about having a printer is you can print out upgrades. Right here is just a filament cleaner box. It's just a box with some foam inside that will clean the filament as it goes through the printer. Just a verbal tip. Running out of filament is very bad. Trust me, I've learned the hard way. If you run out of filament, your print will stop. Or if you have a filament sensor, that's great. It will stop the print. But I have one, and it doesn't work very well. And it's just running out of filament. And the CR10 is terrible because it has that tube, and you end up having to take the printer apart if it runs out. Unless you're lucky and you can cram another piece of filament in there. And some more, if you have trouble with adhesion, bed adhesion is always going to be a challenge if you have any kind of, especially if you have leveling issues. Using glue stick or hairspray is actually really good to have around if you're just like trying to get something to print and you just want to try and fix it. I recommend trying to use those. So with that, we come to the end of our presentation. Thank you, everyone, and thank you to our patrons. We've got a few people here that have their social media up, and if you want to become a patron, you just let us know. And we also have several other social medias that you can join to find out when we're doing more projects or more classes. Or learn more about us. Our website is sporehsv.org, and or we have our parent nonprofit is mycelium.ngo, where we have all our projects listed. We're actually working on a farm bot right now with a local garden. We actually were there this morning trying to put that together, and we're really excited about getting that together. And then also, as mentioned before, we have a couple recycling projects. We have the UAH recycling corner where we have a filament that is being recycled into new filament, and various other projects. So again, thank you very much.